Andritz Hydro is the global supplier of electromechanical systems and services for hydropower plants. Hydropower plants are actually based on a rather simple concept. Water flowing through a dam turns a turbine, which turns a generator, producing electricity. The water in the reservoir has potential energy by virtue of storage at a height. Three basic elements are necessary in order to generate power from water: a means of creating head, a conduit to convey water, and a power plant. When the gates open, the water flowing through the penstock becomes kinetic energy because it's in motion, which turns the turbine to produce electrical energy. Types of hydropower plant. Run of river. Water is diverted from the river, routed through the project, and finally left back to the river at a lower level downstream. Conventional storage. A large hydropower system uses a dam to store river water in a reservoir. Water released from the reservoir flows through a turbine, spinning it, which in turn activates a generator to produce electricity. Pumped storage plants. A pumped storage plant has two reservoirs, upper and lower. The water in upper reservoir flows through the hydropower plant to create electricity. Water exiting the hydropower plant flows into a lower reservoir. Using a reversible turbine, the plant can pump water back from lower to the upper reservoir in off-peak hours to generate electricity during peak period. Components of hydropower project. Following common hydro-civil components are used. Trash racks is a screen of welded bars provided at the intake to prevent entry of floating debris into the water conductor system. Intake gates are provided for regulation of flow of water into the water conductor system. Head race tunnel. Head race tunnel is a channel which carries the water from upstream to the powerhouse. Surge shaft or tank. Penstock is fitted with a storage reservoir called surge tank at some opening in order to store surplus water in case of increased discharge. Desilting chamber precedes the HRT for exclusion of sediments or fine sand from the water to prevent rapid wear of turbine runner. Penstock or the pressure shaft is a huge pipe that conveys water to the powerhouse. Main inlet valve is used to control the water flow into the turbine. Tail race channel or tunnel is the channel through which the water returns to the river after passing through the turbine. Spillway. Its function is to discharge surplus water to prevent damage to the dam or the powerhouse. Powerhouse. Powerhouse has the turbines, generator, control and protection equipment and other auxiliaries for operating the machines. There are two categories of powerhouse. Surface powerhouse. All components of the hydropower projects are on the natural excavated ground surface. Underground powerhouse. All major components of the hydropower projects are underground in tunnels and caverns. The layout of a powerhouse consists of various floor levels like erection bay, service bay, a machine hall generator floor, turbine floor, etc. Erection bay is an area provided for the assembly and disassembly of major generating components. Service areas include offices, control and testing room, storage room, etc. Components of a powerhouse. Main inlet valve. Valves are used to control the water flow into the turbine. When the valve is closed, the water flow is stopped. Hence, valve is also a safety device to stop water flow in emergency. The butterfly valve and the spherical valve are the two commonly used types of valves. Draft tube. Draft tube conveys the water from the discharge side of the turbine to the tail race. It is designed to minimize exit losses. Without draft tube, pressure could drop, causing turbine failure. Spiral case and wicket gates. This is steel-lined conduit used to direct and uniformly distribute the water into the turbine runner. Wicket gates are adjustable vanes surrounding turbine runner to control flow of water into the turbine. Turbines. Turbines are used to extract energy from moving water for the production of hydroelectricity. They operate by forcing water past slanted blades, which spin the turbines. Turbines are mechanically attached to an electric generator, which generates electricity. Most common types of turbines used are Francis. The Francis turbine is a reaction turbine. Guide vanes direct the water tangentially to the runner, and this radial flow causes it to spin. Pelton. The Pelton wheel is among the most efficient types of water turbines. Nozzles direct forceful streams of water against a series of spoon-shaped buckets mounted around the edge of the turbine runner, causing it to spin. Kaplan. The Kaplan turbine is a propeller-type water turbine which has adjustable blades. The inlet is a scroll-shaped tube that wraps around the turbine's wicket gate. Water is directed tangentially through the wicket gate and spirals on to a propeller-shaped runner, causing it to spin. Generator. The heart of the hydroelectric power plant is the generator. A generator converts the mechanical power produced by the turbine into electrical power. The magnetic field between the stator coil and the rotor magnets creates an electric current in stator coil in accordance with Faraday's law of electromagnetic induction. Components of generator. Rotor. The rotor is the rotating magnet part of a generator, which produces a rotating magnetic field. Stator. Stator is a stationary set of conductors wound in coils on an iron core. The rotor field cuts across the conductors, generating an induced voltage. Bearings. There is one thrust bearing and 2 to 3 guide bearings in a generating unit. Brakes and jacks. Brakes are applied at 20 to 25% of rated generator speed to bring it to standstill. Jacks are used for lifting the complete unit for maintenance work. Coolers. Air-water coolers are installed to cool the stator windings. Exciter slip ring. The rotor's magnetic field may be produced by induction, by permanent magnets, or by a rotor winding energized with direct current through slip rings and brushes. Electrical and mechanical balance of plant consists of the systems and components of power plant apart from prime mover and generator. Electrical balance of plant. These are equipment needed to distribute generated electricity outside the power plant. Bus duct. It consists of the electrical conduits that transfer power output from the generator to the generator step-up transformers. Bus duct failure would stop the power evacuation from the generator. Generator transformer is the electrical device that increases generator output voltage to match the voltage level of the transmission line. Switch yard. The power generated by the generating units is pooled in the switch yard and transmitted to load points, circuit breakers, isolators, earth switch, etc. Isolators and circuit breakers are switches that connect and disconnect the generator to the power grid. MV switchgear. This distributes the 11 kilovolts, 22 kilovolts and 33 kilovolts power supply from grid as required by the power plant, and failure may cause blackout if no other power is available. LV switchgear. This distributes low voltage 415 volts AC supply to various electrical auxiliary, mechanical auxiliary motors, LDBs, switch yard kiosks and chargers. LV switchgear failure would cause blackout and no power to start auxiliary. Auxiliary transformers reduce the voltage level from the generated voltage level to 415 VAC. Similarly, there are station service transformer and excitation transformer. Power and control cable. They are used to connect all LT switchgear with the end-use system and to connect all electrical and mechanical auxiliaries in the power plant. DC system, used to maintain the emergency systems like emergency lighting system, protection and control system, etc. DG set, provides emergency supply for power plant accessories and emergency lighting when main AC is not available. Illumination system. It is the normal lighting system which includes indoor and outdoor lighting of complete powerhouse and adjoining areas. Firefighting system. It is the fire protection system to take care of accidental event of fire in the power plant. Grounding. This is the powerhouse electrical earthing system. Improper grounding system may lead to failure of equipment, inappropriate function of protection equipment, especially related to earth fault, and even human casualty in case of fault. Mechanical balance of plant. Hydraulic control system. Oil pumping unit. A system used for transmission and control of forces and movements by means of hydraulic fluid. It is needed for turbine regulation, operation of brake, MIV, BFV, turbine guide vanes, seal control system, etc. Cooling water system. The cooling water system is designed to meet the cooling water requirement of equipment in the powerhouse, such as generator, bearings, transformer, OPUs, etc. Low pressure compressed air system. It is used for generator braking and jacking. High pressure compressed air system. It is used for supplying compressed air as emergency backup for operating OPU valves during AC power failure. Turbine lube oil plant is used for lubrication of turbine guide bearing. Drainage and dewatering system. It is designed for drainage of all water discharge outlets, returns, drainage from equipments, and any seepage from submerged wall of powerhouse. Other systems are also required for proper working of a power plant, which include turbine governors. They regulate the speed and output of turbine generator units by controlling the water flow through the turbine by adjusting the opening of wicket gates or nozzle. Excitation system. Excitation system controls the flow of field current in the generator rotor. This current controls the flux density and thereby generated voltage. Protection system. Protection system performs the function of electrical protection of the unit. There are several protection functions like overcurrent, earth fault, over or under voltage, negative phase sequence, stator faults, rotor faults, etc. Control system. They are necessary to facilitate the automatic or manual operation of the generating unit. Functions include start-stop sequencing from standstill to grid operation of the generating unit, including all the auxiliaries of plant, gate control, switch yard control, station service auxiliary control, etc. There are a variety of inputs for various signals or parameters, and control is based on the logic designed in the microprocessor-based controller utilizing these inputs. Andritz Hydro is involved in the turnkey execution from design to commissioning of hydropower plants. Many of Andritz Hydro's references are still unique and represent world record.